669 parts E and F. For each of the following reactions, 3.4 moles of each reactant is initially present. Determine the limiting reagent for each of the following reactions. Okay, so let's dig on in here. So I have two reactants. I've got, for the first one, I have 3.4 moles of, my toolbar is hiding my, just a second. There we go. I couldn't see what my reactants were, which is never a good thing to not be able to see. So I've got 3.4 moles of C7H16, so heptane. And according to my equation, for every 1 mole of heptane I have, I make 7 moles of oxygen. And I already see part of the problem here, maybe. That little delta H that you see there is supposed to be above the arrow. And, well, that just turned out to be a big disaster. Here, just ignore that little delta H. That little delta symbol there means nothing to you. All right, back to where I was going. So that you have 7 moles of carbon dioxide produced. So that gives you 0. 7 times 4 is 8. 223. So 23.8. moles of carbon dioxide is how many moles of carbon dioxide you can produce with 3.4 moles of heptane. We work it again, 3.4 moles of oxygen. And according to my chemical equation, for every 11 moles of oxygen, I can produce 7 moles of carbon dioxide. Multiply everything on top, divide through by everything on the bottom. So I've got 3.4 times 7 divided by 11 is 2.16 moles of carbon dioxide. So I have enough wheels to make 23 cars. I have enough doors to make 2 cars. So I can only make 2 cars. So that is my theoretical yield. What produced that? What limited my production? My amount of oxygen. So my oxygen is my limiting reagent.
Our running backs, like some of these guys can blossom a little bit.